telescope, and that's a pretty standard arrangement. When you start looking at a really narrow piece of the sky, one of the things that becomes an issue is if things are vibrating, if things are wiggling and wobbling a little bit. If you're looking at a really tiny part of the sky, you're going to get dizzy really sick, because what you're actually looking at swings back and forth and back and forth. So having a really stable mount is very, very important for being able to not only observe things, but especially to image. Because if that star is wiggling around a little bit, then in the image you're going to see this like little line. And we've seen examples of that before in some of the imaging that we have done. There are lots of different ways that you can mount a telescope. There are lots of different ways you can set it up. This is a particular kind of mount called a German equatorial mount. And the issue with mounting a telescope, especially if you're going to try and track something through the sky, is you want the telescope to move easily the same way that the sky moves, right? So all the stars in the sky move at night, they rise, they come up in the sky, and then they set. But they don't orbit around the top of the sky. They actually orbit around the North Pole. And so up in the northern hemisphere we have the star Polaris, which we can see, and basically the entire sky rotates around Polaris each night. So actually they go this way. The stars rotate around Polaris each night. So what we want to do is we want to set up a mount that will do the same thing. And so this mount is actually over here on the other side, so I'll turn it around here. This mount has a couple of things that you have to set up. One of them is we're actually set up for roughly our latitude here on Mount. We're at about 20 degrees north latitude. And so, in theory, this axis of the telescope right here should be pointing straight at Polaris. Okay, so one of the most important things to do at night when we're setting up the telescope is to make sure that this is pointing as accurately at Polaris as possible. Okay? The tricky part there is that usually you want to set this thing up before the sun sets, because it's heavy, it weighs about 75 pounds. It's not easy to maneuver, and once you get the telescope on here, this thing weighs about 120 pounds, especially if you have all the other gear on here as well. So what we do is generally we'll set this up for a very rough alignment. We'll get it fairly close to pointing towards Polaris, towards the North Celestial Pole. And this telescope actually has this mount actually has a telescope built into it, so that you actually can look through here, and there's a way to then use this viewfinder to kind of see if you're a little bit closer to Polaris. And the reason we want to be super duper close is because this thing has a very smart brain in it, and if we tell it, I want to go see the Andromeda Galaxy, you just say Andromeda Galaxy, and it goes right there and points to it. But the accuracy of its pointing is only as good as how well it was set up to begin with. Right? Yeah, you don't just, hi, go to the Andromeda Galaxy, please. Although, if you have Bluetooth and we have the right controller, you can actually set it up to run via your iPhone. And so then if you had Siri, then you could say, hey Siri, take me to the Andromeda Galaxy. I don't know if she would do that or not. I don't know exactly how that would work. So basically then, the key here is pointing the telescope. And the more accurate the pointing, the easier it's going to be to observe the things you want. And particularly when we start plugging cameras in, the better your imaging results will be. Because if you're doing a 10-minute long exposure of something in the sky, and I'm hoping that this group, by the end of the year, we're going to be good enough that you guys are going to be able to do 45-minute or an hour-long imaging sessions, which would just, things would totally blow us away. And also this year going to ask for a color camera, so that we have a one-shot camera. We get the whole color thing right away without having to go through all the filters. If you think about a 10-minute exposure, if you're off from the North Celestial Pole by a little bit, then that means that as the sky moves and as the telescope moves, they're not going to be moving in exactly the same way. And so your stars are going to start to become kind of stretched out. You're going to have other weird things happening, and the image is going to maybe look blurry, or it's not going to look as nice. So having good alignment is really, really important. Once we have alignment, there's actually two axes. There's actually two ways that the mount moves. One of them is it moves this way. Okay? This is what is called the right ascension axis. So this allows it to turn. Basically, if you think again that this is where the North Celestial Pole is, this is the way that the stars rotate. Right? The stars rotate around the North Celestial Pole, just like the telescope would do here. So this is our right ascension. This allows us to have the telescope move the same way that the stars do, as long as it's aligned properly. And then we also have what's called the declination. Okay, and this is the other coordinate that we use to describe things in the night sky. And so between the two of these, we can point the telescope any direction we want. Sometimes it gets tricky to try and point it in some weird direction, but it's also, for tracking, this is the best kind of mount to use if you're going to try and track things through the night sky. We have a power switch. This thing is actually motorized and we'll be able to move. So this usually plugs into I have a marine deep cycle battery that I've converted with some cigarette lighter adapters into a power supply. So we just basically drag it out to the sidewalk out here. Sometimes we'll go someplace else if we're trying to image a particular part of the sky, and plug it in, and the power is on. There's a hand controller that plugs in here. We use the hand controller to set up the telescope. We use the hand controller to basically make sure that everything is working correctly, and that's how we give the mount the instructions. There's also something called an autoguider. The short refractor telescope, the little 80mm refractor telescope, typically sits on top of the larger telescope, and that's the one that has the camera connected to it. It looks at a field of stars. You say, follow that star, and basically anytime that star moves in the field of view, the camera computes what the mount has to do to keep it in the same spot. So the autoguider basically helps us improve our guidance so that we track with the stars better. If we're off a little bit, that autoguiding can sometimes help. Sometimes it's just a big pain in the butt because it's not talking to the computer correctly. So that's the mount. Hopefully, as time goes on, you guys will be able to do a lot of the mount work yourself. So here's the actual body of our telescope here. And one of the important things about having the telescope mounted on here is making sure that things are fairly well balanced. We want to make sure that the telescope is not so unbalanced on the mount that it's sort of torquing the whole setup. So basically this just slides on here and is held in place by a couple of clamps. And what we'll do tonight then is whatever digital camera we choose to use will get mounted right up here, and then that will track with the night sky. Actually, we need to turn this a little bit. So we have the objective. We have the objective here, which is 127mm. So we know from our discussions earlier, the stuff that we did earlier in the week, that this is what determines how much resolution we have. This is what determines how bright everything is going to be. So we have our lens here. Turn so everybody can see. That is a pretty big lens. How are you shooting, Caleb? And this has about a 952mm focal length, so things typically come to focus right about here. And it's just, basically there's a collection of lenses up here, and the rest of the telescope is just a tube that the light travels through. Typically, because size matters, I like to put this on because it makes it look like I have a bigger telescope. Does anybody know what this is? Yeah, there's two things that this does. This is called a dew shield, and it does two different things. One thing it does is it blocks extra light coming in, so like if we're out here and some of the street lights or some of the lights down from Con Poly are on, it can help to block that from falling into the lens. The other thing is that if we go from the straight lens to the atmosphere, we get a big temperature change because the glass is typically cooler, and one of the things that happens if you have a cold glass sitting outside, what happens? it gets all this condensation on it, right? And we call that dew. So what this is designed to do is it's designed to help make the temperature change more gradual, so that this doesn't get exposed to a lot of moisture like that. And we have to worry about that here if it's very humid out. But if it's not so humid out, then it's usually not a concern. But it does happen as the night sky gets, as the night gets colder, that sometimes the dew will form. The telescope itself is fairly light. It's actually, the tube is made of carbon fiber, so it's a nice space-agey kind of thing. Down here is the place where the eyepiece goes. Right, so we have a couple of different things going on here. We have the focusing rack. So I have this large knob here that I can turn that allows me to focus the telescope. There's actually a scale sitting here on the focuser, so that if I need to set something up, one of the things that's difficult, for example, is imaging. If I'm using a camera, then I'm not able to see a live view of what's going on here. So we have to focus things. So one of the things that's handy is when you pop the camera on, you know already where that focus point is, and then you just have to adjust it a little bit to be able to get there. And again, because we have a telescope that's rather large, if you think about it, if you're trying to look at Mars, which is going to be right up here tonight when we look, you're going to have to put your head down here, and that gets to be really painful, and you can faint because all the blood rushes to your head. So we actually put a diagonal on, and the diagonal is basically just a mirror that bends the light 45, actually 90 degrees. And so then instead of having to look at that weird angle, I can look right here, and it makes it a lot easier for us to observe what's going on there. On the focuser, there's another piece here. Let me turn this around. So the focuser has, this is what's called a Crayford focuser. And you can see it has the large knob here that racks this thing in and out pretty swiftly. But then we can also turn the smaller knob here, and sometimes they have this on a microscope as well. We can turn the smaller knob, and basically 10 revolutions of this knob is equivalent to 1 revolution of the big knob. So there's a gearing ratio going on in there. And so this is used for fine focus. This is used to kind of make sure that things are as sharp as possible. So typically what will happen when we go to set up the telescope is the mount will get carried out separately from the actual telescope itself, since I don't want to have, if I drop the whole thing, I don't want everything to go. So typically the telescope will go out second after the mount has gone out. Our telescope has a finder scope. So this is a scope that goes on the side, and basically, if we're trying to find something like Mars, for example, or even the moon, if we're looking through this telescope, the telescope has a very small field of view in the sky, so it can be tough to figure out where exactly you are. So by using something that's more like a binocular type size object, we can put the moon in the field of view. We can center it on Orion, and then when we look through the telescope, we're more likely to see that object. This is a very nice finder scope. This would rival anybody's binoculars as far as clarity goes. The other nice thing is that most finders are inverted, which means that they make everything upside down, which is really hard to then find things because you're always moving things in the opposite direction. You know how, if you guys remember doing biology and you're looking at a microscope, you're like, oh, I want to go down, so you have to move up. You have to do things sort of the opposite way. So tonight what we'll be doing is primarily using this for visual, but we'll mount the camera up on top here and we'll get this tracking, and we can do some things like maybe put a big zoom lens on and see if we can get a nice image of the Sagittarius star cloud, or do some things like that. Are there any questions on any of this so far? So my goal is that at the end of the year, in fact, I want to talk about a solid hint for a final exam question. My goal at the end of the year would be to give you the telescope and say, set it up and point at this. And you'd be able to go from start to finish. Setting it up, making sure this is pointed correctly, going through, setting up all the electronics to do that, and then being able to point it at some object. So now we're actually also set up for this evening. So we can do this. So I will be up probably around 6 o'clock because it does take a little while to set the telescope up.